All right. Perfect. Thanks everybody for attending. We're going to talk about refined, the library. In particular, I want to talk a little bit about refining JSON data structures. A little bit of background on me. My name is Tim Steinbach. I'm a senior software developer at a company called eCentire. We're in Cambridge, about an hour and a half from here. My team calls itself Advanced Threat Analytics. Sounds kind of impressive. It's fun. I don't know if it actually is impressive. Basically what we do is we build data pipelines that basically forward data onto machine learning models. So we deal with data scientists a lot. We have some on our team as well. We have data engineers, etc. So you kind of get the idea. I don't want to talk about myself too much here. Very, very typical JSON interaction. I would assume everybody in this room that has ever had to deal with the JSON API kind of had to figure out what is it actually trying to tell me. It's cool to look at a developer's documentation if you're lucky enough to find one, and it tells you, hey, I have this field IP and it's going to give you something. I have this field at timestamp, it's going to give you something. Typically you would, straightforward, naive, encode it something like this. You have some case class, stuff the IP into a string field, stuff the timestamp into a long. Okay, it's cool to start like that. One of the problems we're going to have with this is validation. Another problem is to just convey additional meaning with those values. So really, we don't want to end up with this case class. It means nothing to me, right? The string, it could be anything. Other than its field name, we have no guarantees that there's actually an IP in it. I could put whatever I wanted in there. Let's move a little further. Like I said, we could do some validation on it. And this is ugly. I just, for the sake of this talk, put this together. We could effectively have a hidden constructor and do some validation with our companion object that effectively returns an option of our class back to us in case all the values that came in were actually valid. Two problems that I would say with this is A, it's kind of verbose. It's not really very readable code. I mean, you just look at the slide and you want to vomit. And the other thing is, once I'm past my constructor, right, I've done this validation. I've made sure it's a valid IP. I've made sure it's a valid timestamp, whatever that means. I pass this object to the next guy, and he has no idea what validations I did. Again, unless I have some sort of documentation or whatever. So it doesn't give me that much. Sure, once I parse my JSON object, now I have an object that's valid for some definition of valid, but I can't convey that meaning to anybody. So in comes this library that I quickly mentioned, and there's a guy on GitHub, Frank Thomas. I believe he's also from Germany, so his name is probably Frank Thomas. Anyways, this refined library, there's a short blob. It's taken directly from its GitHub. Refined is a Scala library for refining types with type-level predicates, which constrain the set of values described by the refined type. It says refined way too often in there. Really what it means is we're going to add additional meaning to our types. And we're also, in the process of doing so, going to get some form of validation almost for free. And we're going to get to the almost part in a little bit. Okay. Now I could do something like this. Again, I have my IP and my timestamp. I'm going to define two types. A, my IP address, and B, my timestamp. So the IP address would still be a string because I need to grab it out of the JSON. So it needs to be related to a string somehow. But now what I'm saying is I'm going to refine it to be a valid IPv4 or a valid IPv6. And there are actually mechanisms in the library that are capable of making sure that these validations are executed, in quotation marks, on that string. And the timestamp, we're just going to declare that we're going to ignore everything before 1970 and make this a non-negative long. Okay. We can go more specialized than this. Maybe your product didn't exist before 2017, so in theory, you could define your timestamp like this, but really this is kind of the norm. I would call it the standard of just ignoring everything prior to 1970. So now our foo class actually conveys meaning, not just in its field name, but in its actual types. Right? If I have an instance of foo and I pass it on to the next guy, he can actually tell that this is a verified IP address. I can see it in the type. That's cool. Now, the question is, how do I create instances of these? Right? I've now defined this type that says it's a string that's a valid IP address. So clearly, I can't just put in quotation marks some IP address and it'll magically be lifted into this refined type. Except it almost is that easy. If I have compile time values, like these up here, I can just import a bunch of macros, and it will do quote unquote these magic things for me. So the first line you see, I tried to define -42 as a timestamp, and the compiler will actually tell me exactly what you see here. Compile error, predicate did not fail. So in this case, it says did not fail because of the way the refined type is defined at the type level. The non-negative number actually checks that it's not a negative number. Kind of, if you think about it, that's exactly the English meaning of it. And so it expects the negative case to fail to prove that this is a positive including 0 number. Okay? A little bit tricky to wrap your head around, maybe not, but this is how it works. In contrast to that, the second timestamp I have is a pretty normal timestamp as we would encounter it, excuse me, in second accuracy. And it compiles just fine. There's a macro that has now validated that this long value that I have confirms to this type that I've declared, and it's a valid timestamp. And the same goes for IP addresses. If I just say hello world, clearly that's not a valid IP address. And again, the compiler will fail, and it'll tell me this is not a valid IPv4, IPv6. In this case, I get a much nicer error message because the types IPv4 and IPv6 are more complicated. So if you got the standard compile error here, it would be huge because it would tell you didn't match this or that or this or that, and you have regexes in there, and it would get very complicated. So it has a custom error message that can get reported. In turn, if I define my localhost IPv4 address or IPv6 addresses, they will compile just fine. Now really, this is only half the story, because most of the time, we don't have our values at compile time, right? Like, it's cute to have this fail at compile time, but it doesn't really help you at runtime whatsoever. So now we still got to connect it back to our JSON blob eventually. So the first step we're going to take is we want to make these kinds of refined values at runtime. And there's something built in for that. There's an API called refined type ops. And just as you can see, you define an object. That's it. No, you don't have to add extra. You don't have to add extra methods. You don't have to define anything other than the two type parameters. Basically, you're saying I want to go to this from that. That's how I explain to myself those two type parameters. And what it gives you is a method from. From is a pretty simple, straightforward method. It takes your original type and returns an either of the refined type or the error message that we just saw that the compiler can also return us at compile time. Well, it's literally the same thing. The string here is not a refined type. It's the error message, right? Same thing that the compiler would return to us. So it could say, again, oh, this is not a valid IPv4, IPv6, or it gives us the right side of the either, which is the valid IP address. Same goes for the timestamp in this case. But it gets even better. Going back to our JSON blob, right? There's integration. I think pretty much everybody will be familiar with Circe, or there are different ways of saying it. I say it this way. Full integration, okay? Circe has a refined module. You just import, And now any of your refined types can be used just like a standard library type in Cirque. Okay? So at this point, the decode method that you would normally use to decode a string that contains a JSON to turn it into your case class, it has no problem decoding your refined types. As you can see here, it'll just give us a decoding failure if any of the types don't line up. And the nice thing about this is not only do you get both predicates failed for IPv4, IPv6, so the error message, Cirque always also tells you what field the error occurred on. So you can see the cursor was going down to the field IP, and that's where the error occurred. So you know exactly what happened. There are other libraries that support refined. It's actually, you have that library refined. There's also there's almost like a little ecosystem that has started developing around it, where other libraries just add support for it. Because it's actually pretty trivial if you look at some of those modules. A lot of times it's just forwarding into methods from the refined libraries, or it's unwrapping and rewrapping types. It's relatively trivial if you own a library to add support for refined. And so these are just the cases that I deal with on an almost daily basis, so I wanted to mention them. Pure config. So the way we build our services, everything is configured through pure config. And we don't just go and say, oh, I want my database URL to be a string. We actually make sure that your database URL has a proper, that you have defined the schema, that you have defined a host, that you have defined the database name. We make sure that things like a password can never be empty. So our password field is actually not a string. It's a non-empty string, which is a built-in refined type, by the way. We have other things. IP is a good example. Basically, what we've found really works for us is we've just ended up refining all the types. If you see some of our classes for the services that I've worked on, you won't see int, you won't see long, you won't see string. Like even if it's a message, okay, a message, it could be anything. You don't know how long, you don't know what it looks like. We always try to come up with some kind of constraint, okay? Again, if I have a message for you, it's not going to be an empty string. So at the very least, I can say it's going to be a non-empty string, and you can expect, you don't have to check. There's not going to be null, it's not going to be empty, it's going to be something sane. All right? One of the things you'll definitely want is you'll want integration with Scala Check, because if you change all your types to refined types and you can't test them anymore, well, it really doesn't help you all that much. Doobie also supports refined types, which is very cool. If you just have a bunch of refined types in your objects and you want to dump it into the database. This module for Doobie anyways, knows how to unwrap them. And same goes the other way around. It basically hooks into them. I don't really understand how Doobie works. I might be lying here. But it seems to hook into meta instances, and that's how Doobie knows how to insert things into the database. Yeah, it works really well. All I can say is we've been extremely happy with it. We've had basically a whole class of bugs eliminated from our code base just by saying, hey, I'm transferring data from A to B, and it's of this schema for sure. It's not just a bunch of strings and ints. You can depend on what I'm giving you is of a valid shape. I've had services where I went and deleted 60 lines of code that was basically just validating stuff, right? I lifted it all into the type system, and I get better error messages, get better maintainable code, and my service is actually down to business logic rather than, oh, make sure the string isn't empty and make sure the timestamp isn't negative, et cetera, et cetera. All right, and I might have a whole lot of time left because I talk fast. So if anybody has questions, shoot now. Over there.
Using
So the question is, can you use refined types in Spark? Unfortunately, I can't answer that for you because I don't use Spark. From what I could tell, I seem to be one of the very few people here that don't use Spark. I would look it up. Honestly, you will likely find something of good use to you. Like I said, I don't understand Spark all that well, so I can't give you a useful answer other than Google it. Yes, please.
Any performance considerations?
Okay, so that's a good question. The question is, are there any performance considerations? Of course, at runtime, you need to validate your type somehow, right? If you have the compile time macros are obviously virtually free. Sure, they hit your compiler, but at runtime, those refined types actually get unwrapped. So this is mostly a compile time construct. And then you re-verify. You got to verify somehow at runtime, obviously, right? There's a minimal hit. None that we could tell that was really worth considering. Especially when you're comparing it to, like I mentioned, my 60 lines of if this, if that, if this, if that. Effectively, you're doing the same thing, except you've gotten it out of your code base. Okay, good question, though. Yes, please.
Is this based on what's the minimum version of Scala for this?
It is not based on type literals, I think they're called. This works, if I remember right, for 2.11 and 2.12. I'm using it 2.12, so it works there for sure. I believe it's cross-compiled against 2.11. So I think Frank wanted to rewrite some stuff to support the type literals. But this is based off of a shapeless effectively. So if you go really crazy, right, and you define your own refined type, and let's say you want a type that's an integer that's between 5 and 21 for whatever reason, okay, you would actually write type witnesses to define that refined type. So you can go through shapeless to achieve that.
Do you have any experience refining a JSON array, say at least one element, more than one element?
A JSON array. And what the elements inside are you refining, or the size of the array?
So a collection of, say, strings.
A collection of strings. I don't see why that would be a problem. So I want to make sure that the array is non-empty, for example. Yeah, I do that all the time.
With reply? Or do you just use regular?
Yes. So I have actually defined and that is unfortunately not yet. I have not been able to contribute that back. I've defined basically a type that will turn my JSON array into a Scala Z non-empty list. So you can write your own instances. Don't get me wrong. You're not obviously not stuck on whatever refined supports. You can fairly easily do whatever you want. Honestly, I imagine there are probably Cats users amongst yourselves. Cats has a non-empty list. You can probably just as easy refine into that. Yep. There's a question there.
Yeah, my workplace, we write a lot of IDLs for our services, and like Protobot or Swagger. Use that to generate SDKs for the service, so we don't have to write them.
Yep.
It'd be really cool to generate SDKs that have refined types.
Agreed.
Have you ever tried to do something like that?
Quite frankly, no. I've thought about it because we wanted to refine. Well, we wanted to protobuf and then refine for a while. Right now, most of our communication is JSON based, so I have it a bit easier because, I mean, as you saw, I basically get it for free. So I have no experience with that. Sorry.
How about polymorphism? As in, could you read into a base class something that has more information in JSON?
Yes, that's actually possible. I've seen it. I've never used it. So take this with a bit of caution. It is possible, from what I've seen, to say, oh, I have an integer that's greater than 5, and refine can figure out that that's also greater than 4 automatically. You don't have to re-verify because you've basically already arrived at that conclusion. So there's some intelligence there. From what I understand, it's relatively basic, so it's probably limited to things like numbers. But it's possible, so if you're interested in extending that, I'm pretty sure that that's possible. Okay? Oh, there.
Can you explain again the process of refining data? What does it mean?
So effectively what you're doing is, well, there are 2 steps to it. Adding meaning to a type. So that's basically defining that refined type. And validating that your input actually adheres to what you've just defined. Okay? So the first step is I can define something like this. Let's go back. There it was. So I can define an IP address is a string that is a valid IPv4 or IPv6. Okay? That's just defining the type alias. And then at runtime, I got to somehow take my string and stuff it into that, right? I don't automatically know that it's a valid IP address or not. So that's where this refined type ops comes into play. It gives me that from method, which will validate. Okay, and that's why I'm getting returned an either, because it could obviously fail or not. So these are the 2 steps that you kind of have to think about. You define the constraint first, and then at runtime, you will want to run your values against those constraints. Does that answer your question? Okay, thank you. Yes, please.
Do you end up having to write your validation code twice, like once in a macro sort of way and once in a Scala value runtime way?
No.
You're making your own refined types.
So if you're making your own refined types, no, that's literally what we're doing here. So if you're looking at IP address, right? We're using predefined constructs, but we're stuffing them together in a way that the library doesn't necessarily anticipate. So this is my own refined type, okay? So the way you have to imagine it, the refined library comes with a whole bunch of constructs. It can say, it has things like, is it equal to this? Is it greater than that? Is it in this range? There's a whole bunch of pre-built predicates that you can just mix and match. You can use Boolean logic, as you can see. I can have or, I can have and. I'm not sure about an exclusive or, but I'm sure that can be figured out. So you have basically building blocks that you just mash together. You have matches regex. Okay, that's actually how this IPv6 one works. So you can mix and match as you please. And then you just define your object for your, basically your type alias. You define it an object, and you're done. So you actually have very, very little code that you really end up writing. Okay. Anybody else? No? Going once, going twice. Thank you.